that you don't need to cram anything, okay? You don't need to cram. So if you remember the last time we were on this call, what we did was we created all the private workloads, right? So we did all the private workloads, all taking 10.0.0/17. So right now we know that within that VPC, we know the CIDR of all our public workloads, all our private workloads. We didn't create the public one, right? We did not. We didn't create this one, but we created this one. And we said it should have a default allocation of /19. This one should have its default allocation of /24, but we didn't start creating the public one, right? Which we're going to create on this call. If we go back to the pools that we created, we know that we do have a public one. So if we go, we click on this, we click on this one, we have the public one. The private, we already have some things inside. So there is this one, there is public, and then there is private, right? In the public, we already have. I think in the private, we already have. It's in the public, we don't have anything. If we go back to our VPC, if you remember, we have, we'll select our VPC. So I think it's the one we created, prod client A VPC, and then we can check the subnet. So you can see we have subnets, right? They're all private subnets. So it's 10.0, 10.64, 10.96, which is very good. The thing is, we don't need this. We don't need to care about these specific IP addresses. We only need to care about the CIDR for that subnet. That's the most important thing. We can always give out, we can create more subnet that takes from that pool. That's all that matters to us, okay? So what we're going to be doing now is to more or less like look at the elements of a VPC, right? So in a VPC, and I think it goes back to when I said that you don't need to cram anything, right? So let's think about what a VPC is. A VPC, basically, it's in a region. It's like your own space within AWS to say, this is how I want my workload organized, right? They are always spread across different data centers if you want your application to be highly available. Meaning if one data center should go down, another data center should be able to take care of the workload on your behalf. And that's why you see that you have private subnet 1, private subnet 2, private subnet 3. They are all in different data centers, right? A data center is basically a physical location. It has its own power, it has its own cooling, it has its own internet. It is way, way separate from the other data center. Subnet is just a grouping, and you're saying, I'm grouping this set of workloads as a private subnet. Anything that I put inside is going to be private, and as private as they are, I want them to just be in one subnet. And then when you create another private subnet, you're saying it goes to a different data center, right? We've already done that. So if you see here, you see that this one is in, if you look at the availability zone, 2A, 2B, and then 2C, okay? So we'll create 3 more subnets. So we're going to be creating 3 more subnets. And the naming is going to be, I'm just going to copy this name somewhere. Let me actually open let me just open somewhere where it is easy for me to write it somewhere. So I'm just going to paste, I think I'm going to call it public subnets US West 2A, okay? Remember, we have to duplicate it because if we want our workloads to be pretty much in the same, we want to have like the public and private also shared in the same availability zone, then we have to duplicate it. But in this time, we'll call it a public subnet, right? So what we can do is that, but before we do that, what are the elements of a public subnet? Let's create that. Let's create that. Usually, you don't need to cram most times, okay? Let's create that. Again, just understand that when you create a VPC, for example, it's always dependent on, it depends on what your network is going to look like, right? Sometimes people think it's a must, you must have internet gateway. But yeah, some VPCs don't need internet gateway. Maybe because they don't really need to go to the internet, right? So it's not a must. It's really not a must, you must have internet gateway. But that's an element, right? And there is also a public, usually you have like we already have subnet. So subnet is already in that box. But what are the other elements? Let's see. The other element will be route tables, right? Route tables. And the reason for route tables is that every subnet needs a route table, basically to tell it, how do I get to, like, this is where like fundamental networking comes in, but you still can understand how cloud networking works, right? In the cloud, in the AWS cloud, you need a route table to just tell a subnet, if you want to go out, this is the rule for you to go out. Like this is the table that tells you where you can go to, right? So internet gateway, pretty much you want to go to the internet, right? And then you also need, if you want, especially internet gateway is really, if you want traffic, if you want to bring in traffic, right, from the internet, you will need an internet gateway. We also need what are the other concepts? There is also the concept of a NAT gateway, right? NAT gateway is now when you want to actually go to the internet from private instances, right? So you can have a NAT gateway. This is also managed service that you can share across subnets. Okay, so you have route tables, you have internet gateway, right? And then you have route tables, and then what else? You have you can also have network ACLs, right? So they call it NACL. So network ACL is just basically it operates on the subnet level, more or less like saying that in this subnet, this is like the network, more or less like this is like the access control list, right? So the more or less like a access control at the subnet level. Some people know security group, but honestly, security group is outside of this at this point, because until you start having workloads, security groups are usually tied to workloads, right? They are usually tied to workloads for you to use security groups. So if I want to look at a VPC, honestly, what you have on the screen is like all you need for a VPC, right? Remember what we did on the right. Yeah, you can use NAT gateway or NAT instance, but I don't really want to do NAT instance, right? Because NAT instance, there are managed stuff that you can do, but usually people we will stick to a NAT gateway, but you can also have NAT instances, right? Good. So if you look at a VPC, this is really the element of a VPC, honestly. Like you have, it's regional, you have a CIDR, you have a data center. In that data center, you have private, public, all spread across these data centers. What we did on the right is we planned it ahead of time, right? Now that we have the planning in place, we can start putting all these things together, right? We can start. If you remember in my CCP, build the Brainyl CCP, we did create, like there was a time we did builders day under our VPC class. If you remember, we actually created a VPC demo lab. So if you remember, this was the diagram we created. So I'm just going to open this image in a new tab, right? But if you remember, we've gone through the same class before, right? Where we looked at an element from a diagram perspective. And I remember I usually say that we sometimes, if you draw a diagram, it helps. And that's why most times when I design here, I usually have like a diagram on the side. And that's just my reason to tell you that you don't need to cram things. Sometimes if you put it in a diagram or you write it as a note or something, there's a way it sticks faster, right? So you don't need to cram something, like put it in your head and be like, oh, I need to memorize it. No, just putting it in a diagram can give you a different perspective about that subject, okay? If you notice, there was a time we did this, but we didn't really just do the full VPC here. I just did a part of it. So if you draw it like this, it shows you exactly what you need and how they relate. And if you remember, I told you that usually a subnet would have a route table that it associates to. In that route table is where you have all the route definition that tells it exactly how to go out. We also talked about like the network ACL would be, it will be bounding the subnets, right? So if you have that understanding, it's just very easy to build. So what we have done before now is we did the planning. So the planning is what we did on the right. And now that we have the planning in place, we've already set up the private subnet, right? We've set up the private subnet. We just now need to start creating the public subnet. So how do we go about it? If you check the public subnet, if you remember, there was a rule. If you check the compliancy, right? We said the person must specify an IPAM pool of public subnet for it to work, okay? So you cannot even create a public subnet that takes from that without specifying this. So I'm just pasting it somewhere so that it will be easy for me to copy, okay? Now that we have that, what should we do? Let's go back to the VPC. We'll go to subnet. We'll start creating our public subnets now. So we'll do our first public subnet. We'll choose the VPC. It's this one. We'll call it our public subnet. Just make sure you name it correctly. So public subnet US West 2A, right? Make sure it ties, because I'm naming it to be specific, I also need to make sure it ties to the right availability zone. So here I'm saying 2A. IPAM allocated is what I want. And this time I'm not going to be using the private again. Remember, we've used private before. We're going to use the US West 2 prod public. So it's going to be automatic. And if you remember, it's picking /24 because that's exactly what we have in the diagram. The diagram says for public, it's going to be a /24, if you remember. Okay. So for those who were here the last time, but the video is also out there, you can catch up with it. So what we are just going to do is do /24. It gave us a name, and the name is this, but we know we need an extra tag. We have to specify an IPAM pool, and then we're just going to mention this for us to create it. Okay. So once we create that, let's see, it gives us a public subnet, and you can see clearly it tells us 251 IP addresses. And if you go back to the diagram, you remember that our entire public IPs has 8,192, and we're saying every time you do the default allocation to be /24, right? So if you go back to that IP, that subnet that was just created for us, it picked the first one. So 10.0.128. So it started from the beginning, and then it's going to be allocating all, it's going to be allocating for us. Again, it depends. We're doing /24. You can actually, utilize more. Maybe in this case, we don't need a lot for the public subnet. So let's continue. So this is the first one. So we will go back to the second subnet. So we'll go to subnet again. We'll choose that VPC, the one that we're looking at. Let's just select it so that it brings all the subnets for that VPC. So we have all the privates. We have all the subnet. We started creating public subnet, right? So let's create another one. So the second one will be 2B. So we're just going to do public subnet 2B. We'll choose the VPC, and then we'll do public subnet 2B. We'll call this one public subnet 2B. It's IPAM allocated. It's going to be from, what did I just do? Okay, so I'm just going to do VPC again. Not sure why I moved away from there. It's going to be 2B. The preference, we have to make sure it matches. IPAM allocated. We'll choose the public subnet here. It's /24. It's already automatically assigned. And we know that the IPAM pool should match a particular name for it to work. Because if you watch that first video, you know that we actually stated a rule that says that for you to create a subnet, you have to follow that rule. Okay, so that one is created. We'll create the last subnet. In this case, it's going to be public subnet. I think it's going to be public subnet C. So we're just going to do this one and do C. And then we'll also make sure it matches. It's IPAM allocated. It's public. Remember, if you also don't want to do this with Terraform, it's usually easier with one infrastructure as code tool, whether it's Terraform or Crossplane or Pulumi, whatever tool you want to use, it doesn't matter. But just know that we've created all. So now we've created all our public sub. Let me zoom in a bit. Okay, so if we go back and we clear the filter, you'll see that we have, for this particular VPC, we'll clear it. We'll choose our VPC. We now have all our subnets, right? So we have private, public, 2A, 2B, 2C, 2A, 2B, 2C. So this one is 128, 129, 130. They're just picking like that. This one has 251, 251, 251. Again, it depends on your organization and your planning. In this case, I'm assuming that we don't need a lot of public IPs, but you can also extend this number if you want. Remember, you can change the CIDR to be /20. You can do it to /21, /22. It just depends on the size you are looking for. But what we did was just to plan it ahead of time. Okay. Now that we have it, what are the other elements that are missing? So if you go back to the diagram to some extent, if we scroll up, we've replicated this, right? We've actually replicated this because now we have a VPC, it has a CIDR, we splitted our subnets now in different easies, right? So we've said public subnet, private subnet 1 should be in easy 1, like that. It just means that you've already arranged for multi-easy support, right? The next thing you want to do is that if you go into VPC, what do you need? You need an interget. The point is, there's no rule for this. Just know the elements of a network in AWS, right? There is more things to it, but just know the building blocks of a network. So there is no one way for you to create it. There is no, don't watch a video and just cram, like more or less like master exactly how they created it. No, just understand the concept and you can create it on your own. You can wake up on the fly and create it, right? Remember that once you know it, you don't need to be creating it manually again. That's when you upload it to an IAC tool because you now know it. The only thing I tell people is that learn it first, do it in the console. And then once you understand it in the console, you can start doing it with IAC. But the good thing is that you're not cheating. You already know, you have the fundamental knowledge, right? Which is the most important. So now that we know that all our subnets are ready, what is the next thing? Maybe we want to start creating, if you go back to our diagram, for example, what do we think is missing? We know that we need like a network ACL, right? We will need one for like a private network ACL. We need one for public network ACL. So let's go and create it. So we'll look for network ACLs, right? There are really ACLs here, but we're going to create it. We're going to create one. We'll look at, we'll call the VPC, right? Sometimes it's good for you to name it properly so that you just don't forget. In this case, I'm doing more or less like a part of the name of the VPC. I'm putting it there, and I'm going to call it public ACL. The reason is just because I'm being specific, right? Just looking at the name. So here I'm saying this, and I'm going to select the VPC that it has, and then I'm going to create this. So if I create the network ACL, this network ACL is there. Now, what you need to look at again is you need to understand what is the default rule here. You can see inbound, allow, deny, blah, blah, blah. You can see right now outbound rules, there's allow, deny, all traffic, blah, blah, blah. So you can actually see here, for example, you can see, how the inbound rules and outbound rules are just immediately you create them, right? So in this case, this is for the public subnet, but again, remember, we've not assigned it. We've not just attached it just yet, okay? We've not just attached it just yet. We've not attached it just yet, okay? But what we've just done now is we've just created so what we've just done is we've created our first network ACL, right? So in this case, we have all our rules, and this one, it says stars. In this case, we don't even have a rule, right? Right now we don't have any rule that gives us allowing. So we need to create more or less like something. We'll create a new rule. We already have that one. And again, if you look at how network ACLs are, they basically start from lower numbers. I think they take more priorities than the other one. So it depends on how you want to arrange this. Maybe you want to create rules on top of it later, but we don't really need to. So we can say all traffic, blah, blah, blah. We need to create an allow rule there. Else, I don't think we're going to, because you can see the default rule that we created is deny, right? So just understand these things, that they're not really rocket science. Just know that a network ACL is basically what decides how a subnet goes out. In this case, we are saying allow all the traffic out. And also we need to also add a new rule. You can call it 100 and say all traffic should be allowed. Save changes. Again, if you want to block network at a network ACL level, you can do it from here. We've done that. Let's create a new network ACL. So again, remember, we usually take the name. So we'll create this one. So we'll suffix it with the name of the VPC, and we'll say private ACL. The reason why it's good for you to separate it is just in case in the future you want to have something specific for a private subnet that is different from what you have from a public subnet. That's why it's good to separate it if you want to, right? So we have public, we have private, right? So the one we just created now is the public one. No, I think the one we created just now is the private one. We just need to edit the inbound rules. We'll add a rule. We'll say 100. Again, you need to understand exactly where you troubleshoot. If something goes wrong, where you'll be troubleshooting it from, right? Sometimes if your network ACL does not have an allow rule, it's not going to allow traffic, okay? So just know the layers in which to troubleshoot stuff, right? Security group, network ACLs are things that, can decide if a traffic can go in or come out, right? So for the outbound rules, we're going to add a new rule and say 100 and just do custom and just say all traffic. For now, we want to allow. If you have any specific thing you want to do with your network ACL, you can, right? Subnet association, we don't have right now, right? So you just creating a network ACL is not enough. You need to associate it to a subnet, right? It goes back to our diagram. So if you were with me in TCP, you know that when I created these, I actually did, I kept an arrow here saying that you create subnet, network ACLs, then you associate them to your, what do you call it, to your subnet, right? So what we can do is that, so it's not rocket science. Just know that network ACLs, you need to associate them to subnets, and even your route tables, you also need to associate them to subnets, okay? So what we can do is we can now start doing a subnet association. This one is the private one, right? So what we can look for is just filter for private, right? Because that's really what we're looking for. We'll just pick all these subnets and say they belong to that network ACL. So all the private subnets, they belong to this client A private ACL, right? So we'll save the changes. Once that is done, we're also going to go to this one. We'll pick the public one, choose. We'll also associate it to all the public subnets, all the public subnets we've created, and then we'll do this and just associate it, right? Good. So if we go back to our diagram, what are the elements? We've just talked about, we just treated a network ACL, right? We've already done this. We planned, and then we created the VPC from it, and then we created our NAT, like a network ACL. The next thing we need route tables. And in this case is where you decide how do you want to structure a route table. Route tables are basically tables that decide how traffic goes out, right? How traffic goes out. So what we can do is we can look for our route tables. Route tables, right now we don't have any. We'll create route table. And then, like I usually do, I'll just put the suffix, more or less like a part of the name of the VPC, just to make it explicit, right? And then I'll call it public, right? Route table. It's good this way just so that you can have name for it. So when I do this, I'm going to create the VPC. and then I'm going to create the route table, right? So the beautiful thing is that it tells us already. So it says that, it created a route and says basically /10.0.0/16 is basically the local network. So that's the beautiful thing in this case, in the sense that it's telling us that because it knows from our planning that the VPC itself is CIDR 10.0.0/16, it says it's putting that in the route. So it means that ideally, locally, the subnets can actually talk to themselves because there's already a route definition for it. Okay, so that one is easy. The next thing we want to do is also now create so this is public route table. We now need to create a private route table also. Remember, we also need to associate. So while we're here, let's just associate it to the subnets that needs it. So we'll go to subnet association. We will edit the subnets. And let me just be sure. This is the public. So we'll go to subnet, we'll edit, we'll search for public, and just pick all of them. So pick all these subnets and just associate them. Save the association. Good. With that in place, what is the next thing to do? We need to also create our private route table, right? So we have public route table. We need to create a private route table. So we're going to go here and then we'll paste this, and then I'm just going to call it private route table, right? I'll choose my VPC. The VPC is this one, and then I'm going to create a route table, right? Again, it gives us that default route, okay? When we start doing higher networking conversations, you'll see how we can influence these routes. They are very, very important, right? This is it. I mean, if you were from a networking background, not less like CCNA, blah, 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 you understand these things, sometimes you are actually doing, router configurations. But in this case, or maybe you are more or less like, tweaking devices. But here, you're actually configuring it in the cloud. But behind the scene, all that is still happening. Remember, the whole idea is that cloud computing gives you devices that are running, that you are seeing from a UI, but behind the scene, they're still backed by traditional devices that you would have used, right? So routers, switches, and the rest, right? But we are not seeing that. Rather, we have a UI to dictate what our rules are going to look like, what our routes going to look like. Okay, good. So if you go subnet association, you can actually go edit, and I think this route table is for private, so we'll go subnet association with edit, and then we'll choose private. And then what are we going to do? So private, we'll just search, pick all the privates, and then we'll save the association, right? Good. So once we have that, what's the next thing we need? Let's go back. So we actually, we're checking the boxes gradually. What I'm just trying to say is that if you understand these things, you don't need to cram anything, okay? I'm still saying that it's good you have the understanding. And that's why when you know these things from that perspective, when you go for interviews, it's easy. You don't really need to cram anything. When you go to interviews, it's easy for you to relate with an interviewer in terms of like, because these things, you've internalized them just by working with them, just by building them, you've internalized them, right? And that's why I always encourage two things: draw diagrams, create a picture for whatever you're doing. I always do it on this call. And if I do it, you should do it also. So, create a picture for it, and draw diagrams if it supports it, and then build it. If you can do those three, nothing is going to stop you. You'll be so confident when you go for interviews because you've done it end to end. So we've created NAT, network ACLs, we've created route tables. What else do we need to do? We need an internet gateway, right? Because internet gateway is really what brings in the internet itself. So we're going to be doing this, and then we're going to be calling it a internet gateway. The other ones, we attach them to to a subnet, right? So NAT ACLs, network ACLs, and route tables, we did associate them to a subnet, but an internet gateway has to be associated to a to a VPC. That's all you need to know. So when we create the internet gateway, we've already done that at this point. So you can see there's a button here that shows up and it says attach a VPC. So attach to a VPC. So which is what we are going to do. We're going to select that VPC that we want. We'll attach the internet gateway to it. That's it. So we've attached the internet gateway to a VPC. So what is left? What is left? We basically now need more or less like a NAT gateway, because now we're dealing with both private and public subnets. And for things in the private subnet to be able to go out to the internet, they basically would need a NAT gateway, right? And if you've not watched any of my previous series, just watch them. But the whole idea is that private workload sometimes needs to go to the internet, and that's why we need like a NAT gateway. So what we're going to be doing is we'll now create a NAT gateway. Okay. So if you go back to my diagram again, you see that depending on how highly available you want your solution to be, you have to create your NAT gateways in the public subnets, right? So in the different data centers, in the different availability zones. So in this case, in the diagram here, I had just two subnets, but sorry, here I had two availability zones, right? But here in this demo, we're actually dealing with three availability zones. So what we can do is that we can go and create our NAT gateways now. So we'll go, where were we? We're here. We'll create NAT gateways. So we're looking at, where were we? So we'll go here, we'll create NAT gateways. So we'll create a NAT gateway. Remember, we always prefix it with the name of the VPC. So this one, right? So we'll do NAT gateway A. So we'll just do A. This is regional. You can have simplify management for multi-AZ deployments. Maybe we can try this one, right? Usually, I think this is also why you need to understand that AWS keeps evolving, right? So all the while, we used to have zonal where you have to create one per zone, but maybe on this call, we should try the regional one, right? Ideally, the way NAT gateways work, in case you've not seen some of my previous videos, is that the way NAT gateways work is that you create three, depending on how many availability zones you have, you create one NAT gateway in each of those availability zones in the public subnets. And then the route tables, the private subnet, if you want to go to the internet, they will use those NAT gateways in the public subnet to go to the internet. That's the way to do it before. So if you had like three if you had three data centers in the form of availability zones, you are going to create one NAT gateway each in each of them. But I think AWS now has room for regional NAT gateway such that you don't need to create it each zone, right? You don't need to have one per zone. So what we can do, let's try that one. Let's use that one. So we'll just do this one. So it can also help you manage the Elastic IPs. I hope you know that there's going to be an Elastic, because if your private IPs, if your private subnets are trying to go out, the workloads in your private subnets are trying to go out, either ways they need like a network address translation that will happen, which is also going to happen at the NAT gateway level, right? So here it's saying whether we want to manually assign or we want to automatic. I love automatic, so I'm just going to use automatic. We're going to be using the regional. So this is new, it's a new feature. So we're trying it out, right? So just know that it's like you're provisioning one per zone, right? So one per availability zone, or you can provision one at a region, right? So which is what I'm doing now. And then I'm just going to create that NAT gateway, okay? In this case, it's going to be pending. It's going to take a while to create. Probably after a while, I think it's going to give us some IP address, right? So let's give it some time. So the NAT gateway is pending. Let's give it some time to create. While we're at that, what else do we need to do? So we have, I think at this point, we're almost set up with our VPCs, right? So we've created our route tables. We're creating a NAT gateway. We have a Network ACL. We have an Internet gateway. What else? What else do we need at this point? We already have our VPCs that were actually created from a plan, right? That's the whole idea of this video, just so you know, helping you understand that even before VPCs are created, you can basically plan ahead. You can structure your IP addresses, how it's going to be, the pools you're going to be working with. And then once that is done, you can now begin to create your VPCs from it, which we have done, right? And we have done all more or less like the structuring around it in terms of like Internet gateway, route tables, NAT gateways. And so this one is still pending. It has a route table. Route table ID is here. I'm not sure. It has this route table. And it's saying that all the networks that are going out to, what do you call it? So everything /0000, it should use the local, right? And then it's saying everything that is going to the internet, it should use this one, right? Which is good. So I think this is actually so this NAT gateway, that's the association. It is associated to this VPC, which is good. So if we actually go back to our VPCs, for example, and we select the VPC we're working with, and we pick our route tables, right? And we switch, you'll notice that these route tables were the ones we created, right? These ones are the ones that have like the subnets attached to them. And then these ones are the ones that were also created. And then they were attached to a lot of they were actually created by the NAT gateway that we just created, the regional NAT gateway, right? Okay, so let's see. I don't know if this is the default. This is actually, I think this is the default route table, this one. But let's see if this one's, so we'll go back. These ones are associated with 3 subnets. Okay, we'll try something basically, but let's see if the NAT gateway has been created completely. So we check, it's still pending. It's still pending. So what are we going to do? At this point, I think we probably will want to create a, we'll create a, what do you call it? What do we do now? We want to create, we still need a NAT gateway. Okay, so it's publicly available now. It has this primary IP address, right? So this is the IP address it will use to get to the internet if you want. So yeah, IPAM is really good. I think that's the whole idea for us to be able to see IP addresses that are compliant. So I think we've passed that level now. We've been able to set up IPAM. We've been able to now use it. We've started using it on our VPCs, right? So if we go further, what else is left? If we go back to our diagram, I think we're done, right? So we have an internet gateway, we have a route table, we have a NAT gateway, we have network ACL. We've created all these subnets. They all came from IPAM. And then the CIDRs for the VPC all came from IPAM, right? That's it. So at this point, we've created like the full structure of what like a VPC should look like. The only thing is that what is a VPC without anything using it, right? What is a VPC without any workload using it? Which is what we are going to start more or less like testing out, right? So what we can now do is we will go and let me see if I can actually have, you know how it is that usually let's go and see. So we'll go to our VPCs, and in here we have VPCs that are here. So they're basically our VPCs here. We have our route tables, and we have this one that has been associated with the, what do you call it? The this one that has been associated with the, this one came from the NAT gateway, right? If you remember, this one came from the NAT gateway. It's an edge device that is a regional NAT gateway, which is good because prior, like I mentioned, you would have created one per zone, but now AWS actually gives you room for you to create regional one, right? So we have that. The next thing we want to do is basically, so we'll go to the NAT gateway and check something. So click on it. So what we are actually going to do is we are going to, so we remember, if you go back to, I think we still need to modify our route tables for our private and public route table, right? So we'll go here because I'm trying to see that subnet to see if I can actually have that route table just because it doesn't really have my subnet attached. It has this rule though, and then it has the edge association. Okay, probably let's try something. So what I'm going to do is, if you remember, usually I can actually manually create stuff if I wanted, right? Create stuff. But if you remember, there is like a quick way we've done this in the past, if you remember, which is Elastic Beanstalk. Okay, I thought somebody would be able to help me, but okay. So Elastic Beanstalk is really what I'm looking for. So what I'm just doing is here, in this case, this one quick way you can actually test your application, right? So I think this one was created a long time ago. I'm not sure. So I'm just going to enter the name of the application. I'm going to delete this. So Elastic Beanstalk is basically just a way for you to create an application, right? So we already have a VPC. Well, a VPC is not as useful to you if you can't test it. More or less like, can you gain traffic from the internet? Can your private instances reach the VPC? Things like that, right? That's how you know that your networking configuration is correct, right? And all that. So what we can basically do is, so we'll still go back to our VPC. So we'll go here. We'll go to VPCs. Okay, no, before we go to VPC, let's actually go to our Elastic Beanstalk. Let's create a new application. So we'll just call it my web application. We'll call it my web application, right? And then we'll say create the application, right? And we'll now create a new environment and just call it, it's a web server environment, blah, blah, blah. Web dev env, we'll leave it blank so that we can get a new. So Elastic, for those who have followed me before, Elastic Beanstalk is just a basic way for you to get a full service that is backed by a load balancer without having to go through all the configurations that would have done, right? If you remember how we set up load balancer, you have load balancer, you have auto scaling group, you have all those stuff, right? But here we're just doing more or less like a quick way. So here we'll just do, maybe let's look for a simple Python application. You'll just go with the default, right? So we'll leave it blank, Python sample application is what I want to go to, single instance, free tier. But I want to use highly available basically, okay? So that we can switch our workloads between these different subnets we've created, right? So I'm just going to create a role and use that role if there is none. Let me see if there is actually one. So I'm not sure if there is. Let's see if there's a service role for that. So let's search for Elastic Beanstalk. I think in the past we would have created one. So you see there is like a service role. If you don't have, just click create role. You should, but we've used before in the past. So I'm just going to do next. We don't need a keep here because I don't want to go into the machine. I'm going to pick the VPC that we've just created. And this is where we're just going to choose the subnet that we want to use. Remember, the subnet we want is basically the public subnet. So let's filter for those public subnets, right? So we'll do public subnet, right? So public. So we'll just pick all these public subnets. And then we don't need the database. We'll just do next. And then what else? We will do the default, the container default. We don't really care. We'll just leave every other thing as default. Monitoring, you can keep all that. Disabled, security group. This is where I think we will need a security group. I don't know if it's going to create one for us by default, but let's create a security group. So we can do, let's actually see if it's going to create a security group for us. So min instance is one. So I'm going to use two instances so that I'm going to use max as 3, okay? The reason I'm using 2 is so that we can actually have workloads that are deployed across the 2 availability zones, right? Remember, we are working with 3 availability zones, right? 3. So we should be able to spread the workloads across the 3 availability zones. So let's go back here and OT, blah, 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 on demand instance. We don't mind. We pick this architecture. Sometimes you can go further and tune these things depending on your workload. You can use T3 micro, T3 small. They are fine. There are many other things you can tune. I'll just leave them as default. Load balancer subnets. Yeah, okay. So this is where I think I probably will have to change something. Okay, so the load balancer subnet is where we want to have the first subnet is where I want to have privates, and then the second one is where I want to have subnets. So where was that? I think we just passed it just now. Don't worry, we'll go back and fix it. So here is the load balancer subnet. Remember, usually when you do like a load balancer, the load balancers will be in the public subnet, the workloads will be in the private subnets, right? So we have this. So we'll say the public subnet should be where the load balancer should use, but we'll go previous, and then for the instance themselves, we want them to be in the private subnet. Okay, that's actually how we test all our that's how we can actually test our VPCs that we just created to be sure it's working as expected, right? So we're saying the instance themselves should be in the private subnet, and the load balancers themselves should be deployed in the public subnet, right? So that's what we did here. So the load balancers themselves are in the public subnet, the instance themselves are in the private subnet. Application load balancer is what we want. Default listener is 80. We're good with it. We don't really have any rule. And then we can do access log. We can keep it however it is. What else? You can do some things. I just want basic monitoring. I don't need anything serious. Managed update. You can set that all at once. I'm fine with it. And then we can do Nginx. I think this is the proxy server. You can use Apache, you can use Nginx. There are many more things you can actually define as part of a, an Elastic Beanstalk. I think if you've seen me, we've done something on Elastic Beanstalk before, right? Here I'm just creating it as a way for us to quickly test. I think it says namespace. What does it need? Let me see if it needs something that we didn't fix. I think I need to bring this a bit down so that I can. I think it's asking for managed actions, enhance else. Okay, yeah, I think it needs enhance else. I don't mind. I'm just going to select it and do next and see if that allows us to go. So it looks like there's an option there that needs enhance else. We can take it. We can do create. Okay, so let's create. So at this point, it's going to create us an elastic load. It's basically going to give us a, what do you call it? It's going to give us a, it's creating an environment for us, right? If you remember, as part of that environment, it's going to create us a load balancer. That load balancer is going to be in our public subnet, which is the one we've created, right? We created our public subnets. The instances themselves are going to be in the private subnet. The instances themselves that is going to host the application that I want to deploy. And then what we are just going to be testing is our route tables, our NAT gateways, our network ACL. Are they configured correctly? Let me see. I just hope it's creating the right security groups. I don't know because I have to verify that. But let's see. Deployments, it's in progress. There is, so let's go to EC2 and see if anything is being created. We can go to EC2 instances. And then we have 2 instances that are running. I didn't create this one, so these ones were launched from the Elastic Beanstalk environment. If you check the subnet definition, so if you see they're taken from 10.0/121, right? Just looking at this IP address, I can tell it is coming from the our design that we had, right? So if you go back to our design, you'll notice that we said 10.0.0, right? Up till 0 is from the private subnets, right? Compared to 10.0.128, right? So let's give it time. The instances are coming up. So we'll just refresh. It's initializing. Let's give it some time. Let's give it some time. Let's give it some time. Obviously, this is going to be backed by a load balancer, just so you know that, it's going to be backed by an auto-scaling group. So I'm very sure that an auto-scaling group has been created for us. There is one here, as you can see. That's what the Elastic Beanstalk environment is using. So if we go back to our instances and we refresh, it's still initializing. Let's give it some time. Let's give it some time. So if it initializes, then we'll see. But again, as part of it, I know that the load balancer would have been created for us. It's this one. And in this load balancer, it is using our public subnets, right? So it's using US West 2B, US West 2C, US West 2A. These are our public subnets that we've created, right? So let's give it time. Reachability. So network mapping. Let's see. So the network mapping tab, I think this subnet is here. Flow logs, route table, it has this route. Public subnet, network ACL. We do have all traffic allowed. The route table. Yes, I think we probably need to edit our internet, our public. That's also the good thing, right? The fact that we're doing this, because now we weren't really testing, but now that we have like a load balancer as part of it, we can actually see what is wrong with our routes, right? So what we can do is go back to our route tables. We know that most of these route tables, especially for the public route tables, so I'm just going to search for public here, right? So this public route table, right now it only has local routes. We need to also edit the route. And that's why I also feel that you need to understand, internet gateway. And we're going to use this gateway and we're going to say the changes. And that's why I also say you don't need to cram, right? Because now in this case, now I know that because I'm installing an Elastic load, more or less like installing an application to it, there's really no route right now for public route, like to go to the internet. So now that it's fixed, you can see the error has gone away, right? So that's why, it's not something I should cram, right? Sometimes you understand that if it's not completely done, you just need to know how to fix it, right? In this case, when he was saying network reachability, we checked and you saw that the route only had route local. There was nothing that says if you want to go to the internet, what you are going to use. And now we've just fixed that. If you are going to the internet, use the internet gateway. So that is fixed. What about the private route? I think even if you go to the instances, for example, you go here. So you go to the EC2 instance that we've created. So first of all, let's go back to the load balancer where we're coming from. I think, where were we? Load balancers is still provisioning. It's active now, which is good. So it's active. It has port 80. It is to forward to this target group here. I don't know if it's healthy. So 2 are actually unhealthy. So health check fails. Probably there's a reason because the instances are not up. So we go to EC2. I teach in a very unconventional manner, and it's just because you need to actually understand, how to pretty much, check how to troubleshoot things yourself. Okay, so if you go here, it says the health checks are failing. So what we can actually do right now, there's no way I don't think I can even SSM into this machine, but my guess would be, because there's really nothing, I don't have that rule applied, but it is possible that the instances don't really have traffic, because if you see the subnets, right, if you check this, if you check the instances that we launched in there, so if you go here, they're actually running in private subnets, right? So this probably, where is this subnet now? This subnet. But I don't think we also have rules that says if you want to go to the internet. So we have private subnets, right? But they don't have rules that talks about like going to the internet. So if you check the route table, there's only a rule that has local. So we need to edit this rule. So we'll go back to our route tables, go to route tables, just search for everything private. Okay, so we'll do private. I think we'll do private. I think it's this one. No. Sorry, what was I checking? We're looking at the private. We've done private. We only have one private route table, right? So we've done for public. Public is fine. We need to do for private. So we'll go to private. There's only one rule. There's really no rule that says if you want to go to the internet, how do you go right now? So we can do the edit. We'll add a route, and we'll say if you're going to the internet, then you need a NAT gateway, right? So NAT gateway, and then you're just going to use the regional NAT gateway, and we're going to save the changes, right? So what we can actually do, because these instances are actually backed by load balancer, we can actually just another thing you need to also check is we didn't really talk about the security group, right? If you check security group, there is a security group here. Let's just make sure it has the right rules, because by default it should have one that was created for us. So it has a rule that says 80 is allowed, and it's coming from the application load balancer. So this one. So on the security group wise, it's correct. So what we can do is that these instances, I want to believe that they were not initialized correctly because the route does not have the rule it needs to go to the internet, pull resource, and all that, because we're using a sample application. So we can actually terminate this instance. I'm just going to skip the OS deletion, OS shutdown, so that's going to be fast. And then once I delete it like that, it's going to provision new instances. But again, one thing you should take note of is that the fact that the instances are actually being deployed in 2A, 2C, right? So multi-AZ environment is where we are deploying to right now. And it follows our diagram. So it follows where we are coming from, right? So it's here. It's going back from like where our design is, which is multiple AZs. So one AZ, another AZ. We're just not using 3 because we said the main instances that we want is 2. And then we can have max instance of 3. So if you refresh, after a while, it's going to launch 2 more instances, okay? So we're just going to do this and wait for it to be terminated and give it some time because there's an auto-scaling group behind it. So because there's an auto-scaling group, it's going to bring in 2 more instances, okay? So let's wait for it to come up. So let's go back to instances, refresh. If we give it some time, it's going to bring up more instances, okay? But at least we know on the public side, the load balancer side is fine because it's just that it has 2 target groups that are unhealthy. There's no targets registered now, but if we go to the load balancer itself, it has an IP address. Let's check the load balancer itself, and then let's check the DNS. Let's check this one, paste it on the browser and see if we're actually even being able to connect. Yeah, so you can see that at least on the public side of things are routed correctly, right? Because from the internet, we can already reach it. But right now, bad gateway, it's an error you also need to understand. It just means the service behind it is not working. That's just what it means. So let's wait for those services to come up now that we fixed the route table. So you can see it's bringing up new instances, right? These instances are running now. So let's give it some time for it to run. And then let's see if it makes any difference, okay? So this one is initializing. Let's go back to the load balancer. Where is it? Load balancer. Let's go back to the listeners, check the target group and see So there's still one. So there's initial. So a new instance is being registered. So the initial health status is still there. Yeah, it's healthy now. Okay. So, and this is why I always tell people, don't, if you understand it this way, right? It just means that you don't need to cram anything. You just need to understand the building blocks, right? My methods might be unconventional. It might be very different from how you've learned it outside, but it's always understand to know the building blocks, like how things are to themselves, right? You can see that when we created our public subnet, the route table was not correct. We didn't have a rule that says, how do you get to the internet, right? That was number one. For the private subnet, we also did not, we saw how there was no rule that says, how do you get to the public internet using the NAT gateway, right? And we can see the implication. The implication is that, first of all, the application could not come up because it couldn't download whatever it needs to download. We also saw that even the load balancer could not be started because it didn't have the right rules and configuration to start, right? So when you understand it that way, honestly, it will stick further than somebody telling you this is exactly how it should work, right? Sometimes it's good for you to experience it yourself. And now that it's working, if we actually go back and refresh that load balancer URL, so if we go back to load balancers, we check the load balancer that we've created, and we pick this one, and we go here, and we load. Now we have a sample application, right? So the point is that, what have we just done? We've created a network that actually works, right? Remember, I always use Elastic Beanstalk if I want a fast solution, and I didn't want to go through the bell and whistles. I can just basically set up Elastic Balancer. So if you ever have a VPC, if you ever were playing with VPC setup and you needed a quick way to test your VPC, private subnet, public subnet, configuration-wise, use an Elastic Beanstalk, right? Just quickly launch an application, choose the public subnet for the load balancer, choose the private subnet for your, for your private, the workloads themselves, which is the EC2 instances in the private subnet. Public subnet, let it be where the load balancer is going to be deployed, and then test it. That's actually what tells you if your configuration is correct, right? So you can see, for example, here, the public subnets are basically where the load balancer is, and the load balancer is reaching the instances that were launched in our private subnet. But it's all following the rules we have established. So it's all following from our design to our, more or less like our deployment, right? So we started from designing the VPC, planning the IP address space, creating a VPC from that, creating the subnet, and then matching everything together. I don't know whether I want to use the word match, but combining everything together such that it works, right? So with this way, if you look at the previous diagram that I had, I didn't really go this, we just demoed with like 2 subnets, right? 2 AZs, but in this case, we are doing 3 AZs, and you can see that we use that both for the public subnet, and then we also use that for the instances. Okay, cool. Honestly, that brings us, I think we've achieved a lot. We've been able to come up with an architecture that basically works, right? A VPC that was created from a plan, is public subnet that is working for. It might be the basic thing. It might be one of those basic things that are out there, but honestly, it's a good, if you understand this part, you've set yourself up for success, because a lot of things you do in AWS has to do with the VPC. And you need to also understand how these segments are created, how they affect themselves, right? Because in this case, you can see it's easy for you to miss one thing and then find out, okay, what could be wrong, and then fixing it, okay? With that out of the way, we've already showed that, yes, you can reach the network through the public subnet, through the NAT gateways that we did set up, and all being powered by instances that are running in the private subnet, right? So instances that are actually running in the private subnet behind a load balancer and an auto-scaling group. We're good. I think we're good. We've been able to show a VPC that works. So if we go back to our VPC is very simple VPC. We select it here. It's a simple VPC. It has a number of subnets. Public, we created 3. We created 3 private. And you can see, for example, you can see some of these IP addresses have reduced from when we created it, because now things are using them. Also, these ones, you can see this is 8186 compared to 8187 because some things are running in there already, right? Cool. We are done. I'm just going to tear down. I usually tear down as part of the resource. I'm going to tear down the things that I feel if you keep them running, it might cost you money. Okay. So the first thing we're just going to do is we'll go to Elastic Beanstalk, Beanstalk, and then tear down the environment, right? And then we'll go back to, I might leave the VPCs running. I don't really, I think I just need to delete the environment first. So I'm just going to terminate the environment, right? So the beautiful thing is that because I created it here, it's going to terminate everything it created on my behalf. So I'm going to terminate. So it's going to terminate. I don't know. It says warning. I don't know why it's saying health issues are failing with, probably this was the last time 7 minutes ago, but we did test it in the UI. It's working. So I don't think it's an issue. So let's wait for it to tear down. And then once it tears down, we're going to delete some of the things we created, especially the NAT gateway. The NAT gateway, if you keep it running, it might cost us money. Yeah, that's pretty much it. So, but the foundation is good. We've been able to, so never be scared of, like, when you see VPC CIDRs, you see, it's not a big deal. It's not a big deal. You can pretty much just understand it, draw it if you want to draw, just for you to internalize the idea, right? And then as you grow, the understanding, you'll get better. That's just the thing. As you continue to work with more things that requires you to directly work with the VPC, and the knowledge begins to solidify even further. Okay, so but just know that these are really the building blocks. I know I didn't mention the security group part. That's because if you followed me before now, we've dealt a lot with using security groups. We've done all that. So I didn't really go that deep, but honestly, these are the elements of a VPC. These ones here are the major elements. Security groups is when you now launch instances. Sometimes you just need a security group just decides how traffic goes from one instance, if one instance is reachable from the other, right? In this case, because we used Elastic Beanstalk, the security group was created for us. The rules were actually also attached, okay? But if you followed me before, you've seen that we've created security groups. So this is probably being terminated, so we won't see it again run. So if we go back to the Elastic Beanstalk environment, so this is it. It is still deleting. I think I'm also suspecting probably used CloudFormation at some point. So let's just do CloudFormation and see if that was actually what was used, so we can keep track of when the environment is being turned down. Okay, yeah, you can see delete is in progress, right? So it's actually using what do you call it? It's using CloudFormation at the back to set it up. So let's give it some time to set up CloudFormation, and then delete the stack it created. Once the delete is complete, we should be good to go. We should be good to go. I'm just going to wait for the recordings to be over, and then I can take further questions if you have any. But usually I go through the series, make sure we record, and so that we have something anyone can catch up with if they want to. Let's see the resources that have been deleted. Let me just zoom this a bit. So delete is complete. Delete is in progress. So it's going to delete. If you go back and check the instances, most likely those instances are gone. They are all terminated, which is good. So let's just give it some time to finish terminating everything. And then once it's done, we're just going to make sure that the environment is gone. So the environment is here. So now the application is unknown. Here is a good place to, so it's gone. So I can tell because this is deleted, it is actually gone. So now that it is gone, what we can now go and check is it's still terminating environment, which is fine. But if I go back, I can check no instances are there, no load balancers are there. Just remember that if you want to check, I think I've talked before about Elastic Beanstalk. I usually use Elastic Beanstalk. I usually use Elastic Beanstalk just to quickly, more or less like bootstrap something. If I want to just show like in this case, we built a network and I needed a quick way to test if my network is working, both public and private, and if all the network configurations are correct, right? Network and Elastic Beanstalk is a very good way for you to test that. You can launch it, choose private subnet, choose public subnet, and just launch, and then make sure that in the UI, you can actually see the application, which is exactly what we did, right? So with that out of the way, I think with that, the only thing I need to delete is, you can delete everything we created. So route tables, whatever we created. The only one I'm going to delete that is the most important is really the NAT gateway, right? Remember, we created a regional NAT gateway, okay? Nice. It was nice to use that feature also because it's new, just so you know now there is now a reach. So if you were in this call, you're preparing for a certification, just know this is what AWS expects from you. As you grow, you need to know the new things, the new way of doing things. Before, if you were creating a NAT gateway, you needed to create one per zone. But now there is actually a regional NAT gateway that you can create, that you can just create for one VPC, right? And it covers the region, okay? So just so you know, that feature now exists. I'm just going to delete the NAT gateway. I'm going to delete, because NAT gateways, if you keep them running, you are going to incur cost. Okay, so I'm going to delete it. For the route tables, you don't pay for having route tables. You don't really pay for having route tables. Okay, so I'm just not going to worry. But NAT gateway, I need to let it go. So let's wait. Let's wait for the NAT gateway to be gone. So let's see, the NAT gateway is gone. So it's still deleting. So let's wait for it to delete. I think that's the only thing that's going to cost us money. We just need to get rid of it. For the other things, having a subnet, you don't need to pay. Having a route table, you don't need to pay. Internet gateway, in as much as you don't have traffic, like traffic going through it, you don't have to pay anything. So, but NAT gateway, in as much as you have it running, you're going to pay. So I'm just going to get rid of it. And honestly, at that point, so it's deleted. It's deleted. So what it means is that if we actually now go back to our route tables, for example, you remember we had to modify our private and public route tables, especially for the private route table. You can see whenever you see a black hole, okay, so if you're also part of this call, whenever you see a black hole, it just means that that thing is no longer reachable. This happens all the time. So sometimes maybe because now we said initially we created our route and we said if you were going to the internet, use the NAT gateway, but now we've deleted the NAT gateway, right? So it just means that this is now a black hole. It's not going to lead us anywhere, okay? Just so it's something you also need to know. So as it is, it's of no use. Anything that I launch here cannot go to the internet. So I can actually delete this rule and just remove this route, right? And save it. Cool. So if you go back to our diagram, remember, I still have a picture here. If you want to actually see it, what it represents, I've done this in the past, like creating a diagram to show you pictorially how you can represent everything that happens in a VPC. The only thing that we actually added into the picture today is not to create different NAT gateways. We only created one, which is a regional NAT gateway. And then we updated our route tables to use that NAT gateway, right? So the concept is the same. Usually you create route tables, associate them with the subnet. You also create network ACLs, associate them with the subnet. And then you create an internet gateway, you attach it to a VPC. I think that's really the most important thing for a VPC. So these things are not the hard part. The hard part comes when you now start dealing with multiple VPCs, multiple AWS environments, right? And that's where you start appreciating why you need to plan, right? So that's why I started from planning. So before you create a VPC, what are the planning effort that needs to go in? How do you distribute the IP addresses? How do you distribute your workloads? Before you ever do that, there's a lot of behind the scene. In some organizations, there are people who specifically do this. But in some places, if your DevOps organization is small, you may be responsible for doing this. And it's a knowledge, if you have, is also very good. Okay. Yeah, that brings us to the end of the class. So we